Hello, everyone. I want you to return with me to a place where servers have pet names, where docs or legends pass through the generations, where you would love to refactor everything if you could only stop firefighting. We've all been there before. Welcome to Legacyland.
Last night I dreamed about the green field again, where I could build whatever I wanted to. No constraints or workarounds in that moment of zen. But then my pager woke me and I knew I'm living in a legacy land, modernizing whatever I can while the past is always chasing me. We missed a payment on our technical debt, but we haven't defaulted yet. We're gonna see if we can outrun entropy here in legacy land.
Last week the build server fell over again. It's leaking memory, but hey, aren't we all? We're on an agile journey, someone tell me when we get there. I still see the waterfall.
I found some code that caused me physical pain, an ancient kludge of sheer incompetency. I called the whole team in and well, I ran get blame. Turns out the guy who made the mess was me.
I'm living in a legacy land, duct tape stuck to my sweaty hands, and nothing seems ideal with weird acquisitions coming into the fold and temporary fixes that are 10 years old, but still we're shipping something real here in legacy land.
Remember, the people who made those long ago technical decisions were doing the best with the resources they had. And what they built is still here because it worked.
That's what legacy means, and we celebrate that, even as we work to make it better.
We're always working on performance and scale, refactoring and optimizing things that got stale, adding value where we can. We're living in legacy land. It's messy and weird, but on the other hand, yeah, so's most of reality. And slowly, surely, whenever I do get to add in something new, well, if I'm lucky, the best reward will be a whole new legacy. I'm living in a legacy land.
All right, ready?
On the electric sousaphone, Miles Ward. Our multi-talented Google Cloud developer advocates, Amanda Lewis and Holt Skinner. My name is Forrest Brazil, and it's so great to welcome you here to the developer keynote at Google Cloud Next, along with my good friend and co-host, Richard Seroter. Hi, Richard.
That was absurd, but that was awesome. Who doesn't want more of that?
Did that just for you, Richard.
I love it.
Hey, listen, it's great to see you out here in Legacy Land. What are you doing here?
Yeah, you know, every time I have built anything successful, which is rare, it has still found a way to become legacy.
Yeah, that's right. Well, honestly, you know, legacy, it's just a fancy word for the thing that works, right? The thing that generates revenue.
That's right. So let's get a show of hands. Who here has been running something that's been in prod for 5 years? 5 years? 10?
There you go.
Do I get 10? 15? Do I get 15?
15.
20. What are you doing?
Wow.
20 years. That is amazing. We'll give some t-shirts. There's a lot of value over the years. That's awesome, right? But there's also some pain. It's not all celebration.
Yeah, there's some pain there too, right?
Yeah.
You know, Google itself is actually turning 25 years old this year. So we've been through our share of growing pains as well. For example, back in 2008, Google was running into a persistent bug on our load balancers, which back then, they were third-party hardware devices. Now, these devices, they couldn't do layer 3 in cap, they couldn't push large configs, and when the network experienced a type of traffic called ARP storms, the load balancers would enter a catastrophic failure mode. And the vendor said fixing the problems wasn't a high enough priority for them.
Right.
Now, our traffic site reliability engineering team said, fix it or we'll figure out another solution. And the vendor said, good luck. So the SREs decided to roll their own load balancing in software on top of commodity Linux servers. And that's how we developed maglev, which is the faster, more reliable technology that's been balancing all our data center traffic since 2009.
That includes all our cloud load balancers, right?
Yeah, the whole cloud load balancing family too. But here's my favorite part of the story, okay? Trisha Weir, who was one of the brilliant SREs who helped to launch maglev, she had one of those legacy load balancer devices bronzed. And here's a picture that she sent of it. Check out that engraving on the top. In loving memory, one feature too few, one ARP storm too many. Talk about celebrating your legacy.
That's right. I think the real moral of the story is you do not mess with our traffic SREs.
That's right.
I'll go one better, though. Let's one-up you. So back around 2010 or so, Redditors discovered an unintentional feature of Google Translate. Anybody remember this?
Oh, that UI, that's a blast from the past.
Yeah,
Wow.
so if you went into this old Translate UI and took this particular sense of nonsense syllables, then translated it from English to German, it came out sounding like this. I mean, it seems pretty harmless.
I love that little, that's my favorite one. Yeah, it's pretty harmless, I would think.
So, I mean, there was one problem with this service, though. It wasn't provisioned to be super large, so that beatboxing feature, would mess things up if it ever went viral. So, of course, it went viral. Every time Slashdot or Reddit thought it'd be hilarious, they'd nail the service, and the service would fall over, and our poor on-call folks would get paged.
Yep.
So the short-term fix was something we all do. We over-provision the service. Now, of course, you could cache and do things like that, but the root problem was that generating sound's expensive. So we had to reduce that disparity between the ease of a single user making a request and then the CPU cost of generating audio. And that's one of the drivers that led us to the architecture innovations we enjoy today, like on-device ML translation and voice synthesis.
That's right. I love that story, Richard, because it reminds us that dealing with these surprising edge cases, right, in legacy workloads, it's a big part of how we innovate and take the next step past that legacy.
Yeah, so look, so far you've heard a bunch of exciting announcements here at Next. You might be asking, all right, how do these help me out in legacy land, where maybe I don't get to choose a brand new tech stack tomorrow, and I have a limited number of innovation tokens I get to spend and business constraints on when and where I can spend them.
So today, we're going to share some lore, if you will, about how Google engineers have rebuilt our own legacy over the years. And we're going to show you how some of the latest Google Cloud features you might have heard about so far at Next can help you do that too. But we're going to need some help. So we invited some very special people to help us out, some of our Google Cloud champion innovators.
That's right.
Yeah.
The champion innovators come from all over the world. They are some of the top experts in Google Cloud, and they're solving real problems every day with Google Cloud. So they're going to help us figure out how to get the most out of all these brand new features. Yep. In fact, we have a pretty strong contingent of champions in the room with us today. Where are you at? Champions?
There's our champions.
There we go.
Awesome. Great to have you here.
That's an enthusiastic bunch.
All right. Well, hey, let's meet some of our champions now.
Confirm it's recording. There he is. And if you could remove your glasses.
With the glasses off?
Get you a little bit centered. Perfect.
When we're talking about legacy,
レガシー
como atada.
It gives me this uneasy feeling. I would say it's a robust CI/CD pipeline.
ML のパイプラインが、最も緊急の課題です。
Best possible hybrid solution.
For us, it's putting generative AI to work.
but then the key thing to me is always the talent, right?
Security. Oh, sorry. Cut you off too early.
Ayudar a que las personas puedan obtener un mejor empleo.
Crash protection server on a Friday night.
Technical level of people coming into the platform.
Me hace querer capacitar a los niños con videos, blogs.
Perfect world.
In a perfect world,
Perfect world.
Training, learning.
taking ideas and sharing it out to the community.
Conceptos complejos de manera simple.
Infrastructure and, modernization. It's all of it together to me.
In a perfect world, all the technicians can make the investments they need to help our systems work right.
That's fantastic. That's all we need.
Thanks so much, champions. Yeah, that's right. Well, over the next few minutes, 4 of these amazing champion innovators are going to help Richard and me take you on a whirlwind tour of 4 big areas where new features from Google Cloud can help us build our next legacy. application development, platform engineering, security, and data development with AI. And if that graphic looks kind of like a roller coaster to you, well, maybe that's apt because all the demos you're going to see today are 100% live. Let's hope this works. But first up, to help us reimagine what building apps looks like in a generative AI world, we have champion innovator and workspace GDE, Alice Keeler. Alice, come on up.
Hey,
Alice, hey, it's so
how's
great
it
to have
going?
you here. Thanks so much for being here.
Thank you.
Alice, you are known as the queen of spreadsheets, is that right?
That is right. I always say that in another life, I would have been a spreadsheet. But in this life, I'm a Google Cloud Innovator Champion, and I'm a big fan of using Google Workspace to automate whatever I can as quickly as possible.
With spreadsheets, right?
The answer is always a spreadsheet. Automate everything, and if necessary, use code.
Oh, I like that. That should be on a t-shirt. So, Alice, of the new announcements at Next, which are you most excited about so far?
Well, I think a lot of us are getting this question from our stakeholders right now. What is the highest leverage use of our time? And generative AI has changed that calculus a little bit, hasn't it?
See, you're a math teacher. I see what you did there.
Yeah, that's right. So I'm interested in Duet AI, but particularly Duet AI in AppSheet. Like, how can I automate with just those tools?
That's right. So recall that Duet AI, which who's heard the term Duet AI a time or two at Next so far? Yeah, a few of us have. It's our new generative AI capability. It's integrated into the core of both Google Workspace and Google Cloud, right? And it can help you write code, analyze security threats, and even develop applications, or so we've been told. So let's do this. Let's take kind of a gnarly use case, and let's see how far we can get into it using just Duet AI and AppSheet before we have to parachute out into some kind of custom code. Sound good?
Yeah, deal.
Awesome. So what should we build?
Gosh, in my day job, I'm a teacher helping people get the most out of Google Workspace. And I hear a lot of surprising use cases that start with a spreadsheet.
Yeah, so how about incident reporting? So let's say, for example, that I'm a school resource officer, right? Or maybe even the shift supervisor on a factory floor. I might want a consistent way for anybody to report safety incidents or maybe just near misses.
Yeah, like maybe just taking a picture with their phones?
Yeah, okay, so let's build a prototype. Now I'm gonna pop into Google Chat where I have the AppSheet bot, which in fact is powered by Duet AI. Now what do we want the features of this thing to be?
Gosh, I mean, I wanted to easily capture data using a phone or tablet so anyone in the school or on the shop floor can initiate a report. The safety team should have an operational dashboard so they can track and escalate issues. And we're going to want some help from IT to establish a method for AI to evaluate the pictures for specific areas to see if they are in compliance.
Sounds good. So let me see if I can get that into a prompt that Duet AI can use. So I need to capture incident reports. Each incident has type, status, description, a date, and each incident should be assigned to, what, a team member, right? So let's put this in and see what happens. Now, I didn't exactly give Duet AI an architecture diagram there, so it's going to be interesting to see how it thinks an app like this should be built. And look at this, what it gave us is a couple of tables. So we've got a team members table, and we've got an incidents table, and as we can see by this team member ID, it seems to think there should be some relationship between them, so that seems cool. We can click on this little pencil if we want to make changes to this, but actually, I think we can also do that through chat. So any changes you think we should make?
You know, it looks pretty good so far, but, you know, can we provide some constraints on the type of incident? Because I really just think that should not be a free text field.
I think you're right. So we'll say type should be major or minor. And then let's see if Duet can actually apply this to our app description. And it looks like that it's actually changed it to a list. Isn't that cool? It constrained that field for us. So it'll want us to look at our app structure again, just confirm that it still looks like what we want and looks about the same. So now we'll just advance through the next couple of prompts here. We can add notifications if we want. Did you know that you can get lots and lots of email from AppSheet if you like?
I love email.
I know you do. Well, just to be kind to your inbox, we'll skip that for right now. And then all we have to do is click Create App. And when I click on this, theoretically, we're going to get a whole web application. Could I get some game show music, please? Let's see what happens. All right. Hold tight. Let's see what happens. So it's going to set up our new app. I feel very excited about this. You don't believe it?
No.
I don't think it's going to happen? All right. So it's going to customize our features, our design. I don't know exactly what's going on behind the scenes there. But here we go. We've actually got an app. Yay.
What?
And so this is actually, let me just orient you to what's going on here. We've built an application. It can be responsive to mobile, tablet, or desktop versions. And you can see that it's created a couple of views for us. One is our list of incidents, and then the other is our list of team members that might be assigned to those incidents. And if you check this out, we can tweak anything we want in the AppSheet IDE if we need to. So we've got data here, and you can see it's created 2 tables for me. It's got listed all of our fields that we need. We can change those types. But Alice, I know you're going to love this. If I click on View Data Source here,
Okay.
all right, and we look at what's actually
I'm looking.
behind this, what does that look like to you?
Oh my gosh. It kind of looks like a Google Sheets spreadsheet.
It does, yes. But actually, under the hood, this is a full relational database. It's running on Spanner. And as you can see, Duet was kind enough to provision some example data for us, which is nice to see, but I actually don't need it. So I'm going to clear that out for now.
Well, Forrest, can we add an integration back into Google Chat as well? So the safety team can be notified and take action when an incident is reported?
A prescience question. Yes, you can. So there is a chat app integration right here in AppSheet, and I can click through that and actually provision that with just a couple of clicks. That might take a second. It's provisioning a new Google Cloud project in the background. So we'll give that a second to run. Now, another cool thing I want to call out is that there's actually an AppSheet phone app. So we've built a mobile app here as well as a desktop app. So do this for me.
Oh, okay.
Go ahead and tap the AppSheet app on your phone. You'll see that
AppSheet.
there? Yeah.
It says incident tracker.
Oh, look at this.
Okay.
Oh, wow, it's already up there
Thinking.
for us. Yeah, and so we've got our incident list. It's empty because I just deleted all that sample data. So that was what, I'm not going to say it was 2 minutes. Not everything takes 2 minutes, okay? But it wasn't that many minutes. We just shipped a web and mobile app, and we mostly use natural language, right, to describe it. So as a developer, this is really getting my wheels turning, right? Like, how much farther can I go before I have to start writing code?
Yeah, good question. Like, ideally, I shouldn't even have to type the incident report, right? Like, I'm imagining trying to do this with a walkie-talkie in one hand while I have a stack of papers to grade. So can I just narrate it with my voice?
That is a great use for another cool thing we just shipped, which is unstructured audio capture with Duet AI. So
Okay.
try this. I want you to hit that
Okay.
plus button
Plus
there.
button.
All right, and then hit the audio button, and we're going to
Okay.
see if we can just narrate this new incident report. So you don't have to, go ahead and hit the audio button for me. You don't have to like narrate exactly what's in each field, which is good because you can't actually see them right now.
Right.
Just kind of tell Duet more or less what
All
you
right.
think should be in this report, and we'll see if it can connect the dots. So go ahead.
Right, so I'm thinking, this is a minor security incident that happened yesterday.
Oh, okay.
Analyze.
See what happens. Ooh,
Oh.
it's minor incident.
Minor incident.
The date is, what is today? Today's the 30th. Yeah, so yesterday at 12 a.m. Okay.
Okay.
So we could tweak that by hand if we needed, but it works. So we'll hit
Okay, so
accept values. Yeah, and then hit save.
Save.
And then I should see that pop right back up here in the desktop version as well, because this is all pretty well synced. Yep, and I've got one incident there. Oh, and I should even call out, you don't have to have this boring list view if you want. We've got table views and gallery views and all kinds of different things that can show up here. Super, super cool. So we've been back to AppSheet, and we've seen that we've actually able to auto-classify that response into our form. So we went from idea to app in some number of seconds. We added these rich user experiences with audio capture and chat. But there's one more big feature, Alice, that you said
Really?
you wanted to add. There is.
I did.
And that's the ability to actually take a picture of our workstation here and see if the AI can figure out if it's in or out of compliance.
Yeah, but can we do it with AppSheet?
Ah, well, no. We're going to have to break the glass and connect this app. Good Lord. Connect this app to Vertex AI.
Oh, well, it was fun while it lasted
It
for
was
us.
fun, but this is where reality kicks in, right? I mean, as a developer with existing workloads, you're likely going to have existing APIs and ML models and so on that you want to make available to other parts of the business. And it turns out that AppSheet lets you put a new front end on that stuff super quickly.
While staying in the Google Workspace world of single sign-on with familiar forms and such?
Exactly. So let's say that I've built an amazing Vertex AI vision model to help identify pictures of workstations that are out of compliance. Actually, let's not say that. Let's show it. I actually have that app available right now.
What?
It's built out in a different Google Cloud project. It's behind an Apogee API, and it looks a little something like this. Okay, cool. So you can see some amazing developer styling going on in that diagram. But what we're looking at here is it's a Cloud Run service that fronts Vertex AI. It's going to run a few little prompts for us, and then it's going to come back asynchronously and call back to AppSheet. So theoretically, we should be able to add that into our AppSheet project. Not there, but if I go back to my data, we should be able to add it. If I click plus there, and we're going to hit Apogee API. And we've got this little inspections API. So if I click on that and hit add this table, it should come through And this is my favorite thing. Check this out, y'all. It actually reads, like if I go to this new inspections table, it actually reads for me the Open API spec, and it pulls in all these fields for the new table. So it's got, whether it looks safe, Vertex is going to determine that, the image that we want to upload, all that good stuff. Isn't that cool?
It is so cool, but I just want to clarify. You can trigger any API here, and that app sheet is able to call via a webhook.
Yeah.
Now, I'm an AppScript fangirl, and I do love that you can invoke calls to AppScript in AppSheet, as well as Cloud SQL and Cloud Storage.
And I love that you said AppScript and AppSheet 2 times in 3 words perfectly. That's incredible. All right, so what we're gonna do here is wire this up as a new view in our app. Google Chat with Duet AI actually did this for us automatically before, but if I go back to my views and I hit plus here, look, here's Duet again. It's actually gonna let us create a new view, and before I do that, I have to resolve a schema issue. So let me go back to my incidents table. Let's see what's going on here. Oh, it requires an image field for the incidents view, so check this out. All right, so we've got a, sometimes things don't always work exactly the way we wanted, but that's okay because I have a separate app on the side. What's a legacy rule? Redundancy, right? So check this out. I've got another application up here that I can use. So in my inspections list, I can actually wire up a view. And it looks like this. You can see I've got this inspections list right here, and it's got a sample workspace here with fire extinguishers and good things like that. So now we should be able to submit our own pictures back to Vertex AI to evaluate them for safety.
Okay.
So if you go back to your app view here, we're going to go back to our app that's good and perfect and working, our cool corporate app. All right.
Very good.
And then go ahead and hit that plus button.
Okay, I'm going to hit
and
the
let's
plus
see if we
button.
can capture a picture.
And I see that we're going to take a picture. So can we snap a selfie of us?
Let's take a selfie of the whole room. Does that work?
Oh, that works.
Awesome.
All right. So take a photo. Here we go. Everyone say app sheet.
App sheet. Awesome.
All right. Okay, save.
Let's hit save. All right, and now if you pop open this card here,
okay,
it's going to take a second for Vertex AI to read this picture, and I want us all to just take a moment and enjoy this live demo moment that we're in together. Isn't this wonderful?
It's the best.
Just sit with this for a minute. Don't feel uncomfortable. Feel comfortable here. This is a great place to be, isn't it, Alice?
Okay.
And look,
here
we've
we
got
go.
this. A man and a woman are posing for a picture in front of a screen that says broadcasting on it. That's not too bad.
That's not too bad.
Awesome. And it says it looks safe, so we're in compliance. Amazing.
We are safe. I love this because everything from the cloud function backwards can be owned by me, the developer, and my team. But this gives me the option to let some of those business teams put together their own dashboards and reports and so on, and lets me focus on where I can provide unique value.
That's exactly right. So in just a few minutes, what did we do? We shipped a web and mobile application prototype using natural language prompts. We built in audio capture with Duet AI, and we called out to other APIs and machine learning services on Google Cloud. All that is table stakes now.
Right? So that just means we get to think even bigger.
Always. Alice Keeler, thank you so much for being here.
Thank you so much, Forrest.
Amazing.
This was fun. Thanks, everybody.
Appreciate you.
My name is Anna Berenberg, and I've been an engineer at Google since 2006, and now I'm engineering fellow in Google Cloud. When I moved in cloud in 2015 to work on networking products, I noticed that some of our engineering teams were having trouble with development velocity. So I asked a question: how long does it take to make a small change, as shipping a single Boolean, true or false, for our global load balancer? Think about your own products and ask yourself that question. How many engineers does it take to plumb a bool through your stack? While you're thinking about that, let me show what our architecture looks like. This is a real microservice graph of the path the bool had to travel from the time customer had to configure it to the time it took effect on the load balancer. This involved 8 teams: an API design, a management, control, data plane teams, UX, UI, tech writers, and more. All these teams were located in 6 offices reporting to 3 VPs. To ship that bool, I had to convince all 8 teams to make the feature a priority. Just thinking about that makes me tired. But even I succeeded at that, with the dependencies between the team, individual priorities, and competition for resources, it would take 6 months to deliver the feature. For 1 Boolean, we had to speed this up. How do you build a platform where product teams can develop fast? The short answer is a combination of vertical and horizontal ownership. We had to empower each vertical team to deliver a feature without this endless matrix of dependencies. And we had to build extensible but still shared horizontal infrastructure that everybody could use. First, we emphasized pluggability in our horizontal infrastructure. Second, we've advocated the use of open source tools and APIs wherever possible for portability. And third, we doubled down on what I reuse of these extensible layers. I call it one of everything effort. One network, one workload identity, one artifact register. Over the next few years, these principles inform the elements of our modern management, control, and data planes. And while we still have lots of work to do, over time, we move faster and faster. For example, our traffic director team built on this new infrastructure to cut their time by shipping a new API from months to a few weeks, deployed in all regions in production. I believe that as developers, we need to think how platforms and product architecture enables development and release velocity. Whether it's through pluggability, portability, or reuse of shared services, our goal is to deliver the best functionality as quickly as possible, 1 bullet at a time. Thank you.
That sounds familiar, doesn't it? That's a pretty common thing that happens. So thank you, Anna. She makes us think in platforms every day, which is a privilege. So look, so far we've seen how far Duet AI and AppSheet can get you when you want to add new workflows to existing systems. But let's be real, a lot of the things you might be working on still involve a lot more traditional cloud building blocks. You're slinging containers, you're tweaking release pipelines, and we want to build those platforms as efficiently and reliably as possible. So to help us learn how to do that, please welcome Google Cloud Champion Innovator, Lucas Carlson.
Hello, hello,
Lucas,
hello.
Great to have you here.
Stoked to be here.
Yeah, I can tell. You're pumped. Lucas, what is your kind of biggest focus right now as you're thinking about managing infrastructure for cloud workloads?
Well, I would say the 3 main things that I'm always trying to improve. First, how our applications respond to scaling events. How do we better handle surges in traffic?
Sure.
Second, we want to make sure the infrastructure is easy to maintain for our platform engineering teams, so they can spend more time doing things that add value rather than just keeping the lights on. And finally, we always want to make sure that we can build experiences that are more personalized for our customers.
Nice. Well, I happen to have an existing workload here I want your thoughts on. It is a dynamic Python app deployed to Cloud Run. So for anyone to follow along, not right now, you're focused on me, but later, I got this from one of Google Cloud's Jumpstart solutions. So these are guided deployments for a bunch of different application scenarios. You can check them out anytime. It's an amazing way to try the cloud. So let's take a look. What I'm going to be showing you here is one of the Jumpstart solutions. This is a dynamic web application I just deployed. You can see we show you the reference architecture. There's tutorials built in, and you can see it's pretty straightforward. Right, I've got some containers in Cloud Run. I'm using Postgres. I'm even using Cloud Build for CI and CD here.
And I see you got Firebase for your CDN, so sweet.
Nothing gets past you. Yeah, that's right. So look, this is a great app for a retail store, but let's say it was a V1. We've learned some stuff, right? That's been running in production a while. We've seen some issues we want to improve. So first, we want to revisit some of the assumptions on scale, functionality, and even deployment strategy. So we've learned we've got some spiky usage and need to scale. So what's my plan there?
Well, there's been a lot of new features released recently, in Cloud Run especially. And so maybe some of those might be useful here.
I like your thinking. Let's start off with how we might handle surges in traffic here in Cloud Run.
OK, so the first thing you want to do is check your minimum and maximum instances.
All right, let's see what we got.
So let's see.
Yeah, look, I'm being cheap.
So it looks like you got your minimum instances set to 0. So let's bump that one up to 1.
That's fair.
Great. With your minimum instances set to 1, you'll always have at least one container running ready to serve traffic. Now, we should probably keep an eye on utilization, so let's check on those max instances. They might need to be raised as well.
All right, I'm not made of money, so we just got to
Okay.
that limit there. So setting that minimum instances bit solves that 0 to 1 problem, but as those instances scale up, I still have a cold start, right?
Indeed. So there's actually another really cool feature that came out of preview recently that you might want to experiment with. It's called CPU Boost.
All right.
CPU Boost allocates more CPU at startup time specifically to reduce your cold starts. So this can actually cut startup time in half for some workloads, but it's actually language and package dependent, so you might want to test it out for yourself.
All right, yeah, it's just a single checkbox. I feel so productive. So look, the initial experiment proved that people like the app. We'd fixed some of the scaling, but now we want to push it to more places, from just one region to maybe multiple. This is where Cloud Deploy can come in. It's one of my favorite services.
Mine too, actually. So Cloud Deploy is fully managed, so it works with GKE and Cloud Run, and it's actually also seen a ton of upgrades since being shipped last year.
Right.
For our app, we want to make sure that we can move the app from dev to test to prod.
Okay.
Perfect. So Cloud Deploy also recently added the ability to deploy to multiple targets in the single stage. So for example, imagine deploying to 3 different regions at the same time. That's super useful.
That's super nice. Yeah, I love that. So I can trigger this pipeline with a single CLI command. I can even do it in the UI now. They just added that. In real life, you'd probably run this as the final step in your CI process.
Exactly.
All right, so let's jump to the console and see this in real life. I just deployed this backstage. Here we go.
Okay, so what I really like about this improved UX in the Cloud Console here is you can see all the things you need to see. For example, you have your running pipeline here, you have all the DORA metrics, and then you can see all the information about each release.
Yep, but even promotion between environments is easy. Canary deployments, it's awesome. So if you try one service after next, try Cloud Deploy. So look, we fixed the scaling needs of our app, but what about some functional improvements? We got the easy stuff, but now let's actually kind of fix some of the app. We've noticed that it's a retail app, right? So we have some abandoned carts, a little more than usual, and we want to poke those customers.
It's a good idea.
I don't know, let's see if Duet AI and Cloud Workstations can help us write some code.
Excellent.
You can't say no to me. All right. So if we look at the application, there we go.
Okay, so I'm a big fan of Duet AI doing auto-completion of code, but also it can generate entire blocks of code. Here, for example, you have a comment. Just from that, we can generate all the code we need to talk to Postgres database, to loop through the rows, and then to email each customer that has an abandoned cart.
That's right. I like your confidence, though. Let's see. There we go. Yeah, so generate a ton of code for me. Great. Look, my parents raised me right, so I'm also going to add some test coverage to this. And so right from the IDE, I can pick the operation, or even do it right from chat, but I could pick the operation and say, generate unit tests. It'll jump over to the Duet AI chat, right, where we can ask questions, but it'll also throw me some unit tests, which I can copy back into my code, run them, and make good choices here.
I love this feature so much. I'm actually talking about this a little later, so feel free to come by to that.
Nice.
So in reality, you wouldn't want this background task that's going to be emailing people about abandoned carts to be like built into your web app.
Right.
You probably want to run it as like a scheduled job or a cron job in Kubernetes or something like that. Now for me, actually the way I prefer to do this these days is using Cloud Run Jobs, which is a new run to completion capability for background work. It hides all the infrastructure complexity, just like everything else in Cloud Run. Serverless.
Love it, serverless. So let's deploy this new email reminder service to a Cloud Run via the job. We can jump back into the console. And you can see, look, it's really easy to build new jobs. If you like Cloud Run, it's the same sort of simple process. Pick a container, pick how often it runs, and you're good to go. I can use the UI, the CLI, even Terraform to deploy this.
Terraform.
So once I have the job running, we can see that this email sender is set up to run on a schedule on a regular basis. And when it's not running, it costs me nothing. Serverless.
Serverless.
Awesome. So let's take a step back. Think about what we just did here. In just a few minutes, we made our application more performant with CPU boost and instance configuration. We use parallel deploys to actually serve this in more regions, to different users. And then we're running fully managed Cloud Run jobs without writing a whole ton of code that we have to maintain.
Perfect.
Yeah.
I would recommend that if you're using Cloud Run, you might want to take a few minutes and check out some of the recent feature announcements and see what capabilities are available to you. That team moves pretty quickly, so you may be surprised at what you find.
That's right. Well, let's hear it for Lucas. That was awesome. Thanks, bud.
Thank you so much.
And now, it's time for another legacy law.
December 9th, 2021 was a dark and stormy night. Okay, it wasn't stormy. We're in California. We don't do that whole weather thing. I was living in a house with 2 other senior engineers who work on Google's technical incident management team. And we knew something like messy was going down when everyone's pager woke us up at 3 in the morning. Turns out there was a 0-day vulnerability in a little open source Java library called Log4j. My name is Adrienne Walser. I've been a technical program manager in SRE at Google for more than 10 years. And I work in incident management. All right, cue the music. Whew, that makes me sound cool. Log4j is a popular logging framework for Java applications. And this 0-day announced a well-publicized way that unauthorized users could execute code on your computer as you. That's scary for one computer. Multiply that into the billions to represent all the production services, all the internal applications, all the build tooling. Any customer compromise is unacceptable. And this 0-day announcement kind of kicked off a race against the clock to patch everything before any malicious actor can try anything. Our security lead immediately said, "Security folks, we need a patch and we want full forensics on any potential exploits. Technical incident response team, tell affected folks what's happening and roll out the patch." Easy, right? Well, this is where Google's legacy is kind of a double-edged sword. Google Search was released in 1998, and ever since, our product lineup has been expanding through innovation and acquisitions like Android, YouTube, Looker, those folks from Mandiant you heard from yesterday. This means that our systems do not have consistent backends. So how do you determine who's calling the Log4j library? Who's even responsible for managing that? We weren't just looking for a needle in a haystack. We were looking for 1,000 needles in 1,000,000 haystacks. We don't know where the haystacks are located, and some of them might not even be hay. So how can we make this happen? Super fast, at Google scale. Clear communication and coordination were key. So my team went back to the basics, breaking the problems down into smaller, manageable chunks with old school classics like spreadsheets, documentation, and flowcharts. I love flowcharts so much. Here is the original chart that I drew to help our teams follow the right process for patching Log4j. Doesn't have billion steps. It just communicates as directly and simply as possible what every team needs to do. Now, we never found any instance of a successful exploit of Log4j at Google. But a week of round-the-clock security updates left us feeling rough. Incident management it's a human expensive activity, and it really takes a toll on the people involved. That week, my household went through like 2 pounds of coffee beans and 0 showers. Not cute. But if you were on Google Cloud that week, you had one less thing to worry about. We were a well-organized force of caffeinated brain power, so you didn't have to be. Now, moving beyond our back-to-basics approach, we've since established a specialized cloud technical incident management function to provide clear communication and coordinated responses to future incidents, delivering that kind of cloud customer experience that our partners deserve. May your pagers stay silent. Thank you very much.
Wow. Thank you, Adrienne. Boy, who here remembers where they were the night that the Log4j vulnerability dropped? Yeah, it was a sleepless night for a lot of us, but thankfully less than it could have been, thanks to Adrienne and her team. Okay, well, hey, it's great to be back with you. Let me, without further ado, introduce you to our next champion innovator, Mark Johnson. Mark, come on up here. Mark, it's so great to have you here. Thank you for being here. Amazing. I've got to ask you a question, though. You have 14 Google Cloud certifications. Why would someone do that to themselves?
Well, Forrest, it's great to be here. And let's say about those certs, I love learning, but I love pain.
Yeah, well, apparently, given that you also work on cloud migrations in your day job, is that right?
Absolutely, all the time. And, you know, working with big enterprises, it's a lot of fun, but change is always constant.
Always a constant. And listen, we've explored how some of the latest Google Cloud features so far can help us build apps in new ways, right? And how they can help us run them faster and easier. But in the real world, in the legacy world, we have even more things to think about, don't we?
So you know we got to talk about security.
Got to talk about security. So take, for example, that little Cloud Runback app that Richard and Lucas were looking at a moment ago. What do we need to do to make an app like this and its deployment process safe for production?
So the first thing I would ask is those Cloud Run services that you were deploying, how are we going to vet what's packaged into those container images? And what's our software supply chain security story?
Ah, yes, the dreaded S3C. So I like to think about S3C in three pieces. Number one, how are we securing our developer environment? Yep. Number two, how are we ensuring the integrity of the build process itself? And then finally, how do we protect that app once it's running in production? So let's begin where all good things begin, in cloud workstations. I've got a little Python app here. It's pretty small so that it will build fast, but it's still going to take a minute to build. So I'm going to push it, and while it's building, we'll dig into the S3C enhanced pipeline that you can see I've built here in my cloud build.yaml.
And then, yeah, people like cloud workstations for the convenience factor, but I definitely think it's underrated as a security tool. You don't need to stop at, hopefully, people are doing the right thing. We can actually create a policy that enforces least privileged access.
That's exactly right. So let me just kick off the build of this app here, and it's running. And while that's running, let's take a look at a previous run, actually, that succeeded. So I've got Cloud Build up here, and you can see I've got a couple successful runs. And when we take a look at this, notice we've got a bunch of steps, let me pull this out so you can see it a little bit better, that are leading us down to something called binary authorization.
And binary authorization is basically a policy we can set at the org level that says, yes, this container image has passed our security checks, and you're allowed to deploy it.
That's exactly right. So if I jump over to binary authorization here in the console, you'll see that not only do I have the policy itself, but next to it I have something called attesters. You say, what are attesters? Let me scroll out so you can see those a little better. Attesters, I like to think of those kind of like cryptographic Pokemon, all right? And I'm going to collect those along the way in order to earn that binary auth checkmark at the end of my build process. So the first one you see here is called Assured OSS. Now, Assured OSS is a repository of packages that Google pre-vets to help make sure that my Python packages aren't malicious. How do I make sure that I'm using Assured OSS? Well, I get to decide. In this case, in my cloudbuild.yaml, I'm calling a script called assured OSS binauthz.sh. And that's actually going to check these packages. It's just doing a compare. And if it finds some that aren't in Assured OSS, it's going to fail my build. Otherwise, it'll update the attester, and we'll move on.
And this is why it's so important to have a hosted build process, all those checks running on the cloud build side. So if you have people pushing code, these attesters are not going to get signed.
That's exactly right. Yeah.
So I also see you have an attestation to validate our container structure as well.
Yeah, you can see that right here. And then I've got a third one that's actually making sure that if I've got any vulnerabilities in my containers that I flag the build, and I'm using something called Critus to do that. That's an open source security policy enforcer that uses the Google Cloud Container Analysis API. It's super cool.
And for those of you out there trying to be systematic about how you put together a software supply chain security flow like this, I do recommend you check out the SALSA levels at salsa.dev. They can help you identify how mature your security checks are and what you may be missing.
That's right. So if I go to Cloud Run, where again I have the most recent revision of this app running, and I move over to the Security tab, we can see in this Cloud Run Security Insights view what all this looks like when the attestations pass and the binary authorization succeeds. I know it's a lot of metadata on each step, but you do have your salsa build level for you here. You've got any fixes that you need to look at, and you've also got your provenance. So I'll zoom in so you can see that a little better. Not out, in, how about that? You can see, where this build came from, where the images were, what time you last messed with it. All those things that can be hard to find unless they're pulled into one place, which here they conveniently are.
And it's also important to call out here that all these insights are also available in the new GKE Enterprise now via the Fleet View.
That's right. So if you haven't seen this yet, because I know it's new, this is what the Fleet View looks like for GKE Enterprise. I've got a couple of GKE clusters running in this environment, and you can see I've got this kind of top-level view that shows me any misconfigurations or vulnerabilities in my environment. I like that it has this concerns tab. I want a concerns tab for my life. That would be super cool. Have all of those things stack ranked for me, but at least we have it in GKE. Actually, let me show you one other thing that's really cool. We have this advanced vulnerabilities section down here, and these are not just container level vulnerabilities, it's actually going down to the language package level. So you see these Go vulnerabilities that it found? It's finding those in your running containers.
And I love how this isn't just some point-in-time assessment that happens when you publish something to your container registry, which you can and should do, by the way, and Artifact Registry can do it for you, but you can actually use this to assess risk for containers that are currently running in production. And the best thing is, there's no cost to run either of this. So I tell all my clients who are using JKE, just turn on security posture in that Fleet View, literally no downsides at all, and it can come up big for you someday.
That's right.
So let's get back to that build. I kind of feel like we should break something, make it real.
I agree with you. I don't believe something's working until I've seen it fail, so this is where I come clean. I confess to you that before I pushed that code just now, I secretly took one of the CVEs out of the allow list in our container analysis step, and so without that, we should see that our build has failed successfully, and it has, so that's good to know.
Forrest, you double-crossed us. You're playing games.
An insider attack. You got to watch out for those, too.
So we should also call this out in certain situations. If you choose to bypass binary authorization enforcement and deploy or serve a container that violates the policy, you can click the break glass button along with a justification.
That's right. So you can see here all this scary red text saying that the binary authorization failed, and I can click that break glass button. This will be captured in the cloud audit logs, but of course the permission to bypass that should be provided very selectively, if at all.
Don't make me get on or go on a tangent about least privilege access for us. We got to lock this down.
Got to lock it down. So we've looked at how we safely get our code to production, right?
Okay.
Now we've got to look at how we keep it safe once it gets there. So let's go to another of my favorite places in Google Cloud, which is the Security Command Center. And I want to jump into the vulnerabilities view, and let's just see if we have anything that jumps out at us about our current environment setup. So you'll see there's going to be a bunch of things that pop up here. Some of them I'm more or less concerned about, but it's this admin service account that really jumps out to me. So I'm going to drill into that for just a second. And you'll notice a couple of things here. Number one, if I jump into this, what do we see? Something's loading here for us. Hopefully.
Hey, Google, make it go faster. All right, there you go.
There you go.
Awesome. What? AI generated summary is actually generated by Duet AI.
That's right. Yeah, you may remember this from the main keynote yesterday, but it's going to give us some verbiage about why it's not good that we have an admin service account with all these extra privileges. But watch this. We can actually go deeper than just a summary. If I click on the attack score itself, these attack exposure scores you'll see next to these vulnerabilities now, and that's just based on, we rank these vulnerabilities as high, medium, or low concern. We have a numeric score assigned to those. You can actually configure that if you want, but a high score is bad, low score is good. It's like golf. And if I click on this number 21 here and select the organization, you should see something super cool, which is our attack path simulation. So let me zoom in on that so you can see it a little bit better. What do you think about that?
Very nice. There's a lot of boxes. Honestly, it's making me a little dizzy.
Yeah. So the good news is, I can actually little summary there too.
Whoa, another AI Duet summary.
Another Duet AI summary. We are killing this, man.
Nice.
Anyway, look at what Duet is doing here, right? It picked up a number of things for us. We've got a secure service account key that's available from the public internet. I like these little red exclamation points here because it actually points to if we have other related vulnerabilities. There's kind of this fractally integrated set of problems in our account. And we can kind of explore that in any direction. It's like choose your own adventure. And it's all mapped out for us here in this nice little attack path simulation. And it brings us all the way down to our demo bucket, which is where we have our build log stored. So all that build metadata we were creating before is actually potentially exposed right now, and this is a good note that we need to fix it. So yes, that's where we're at. And so let's think about for a second what we did here. I've got my service accounts. We've popped open these boxes to get Duet AI summaries of the problem. And ideally, we've pointed us towards steps that could maybe keep our environment safe.
I'll be honest, I feel like my mind just melted a little bit here. One of my long-standing, forward-wishing looking just goals for cloud overall, just say, hey, AI, just tell me which of these containers have vulnerabilities, which policies are over-permissioned, and just give me the steps to remediate them. Don't make me guess. Don't make me put together a bunch of tools. And it really feels like we're starting to get there.
I think we are. Mark Johnson, thank you so much.
Thanks, Forrest.
For helping us dive into security on Google
Yes, sir.
Cloud. Appreciate you, man.
You've got more.
Here at Google, we like to say that the best backend migrations are the ones nobody notices. And since 2021, we've been conducting a massive migration right under your nose. My name is Sudev Bahra, and I'm an engineering manager on the Google Workspace team. And this spring, my team wrapped up one of the biggest data migrations in the history of the planet. We moved every email in Gmail, that's billions of users, trillions of messages, and exabytes of data from our legacy storage system to a more modern system on Spanner. And I bet you never noticed a thing, except for maybe faster and better inbox search. But behind the scenes, this migration was a very big deal. You see, Gmail doesn't close at 5 p.m. or on a Saturday night. The whole migration process had to be zero downtime and zero corruptions. Every byte of every email had to be preserved perfectly. All while billions of new messages are flying through the system every single day. So how do we do this? We started off by building an API layer that abstracted away the reads and writes from our previous database and Spanner, so we didn't need to maintain two code bases. And as part of this process, Spanner became sort of like our system of record. So all new transactions were first written to Spanner, replicated, and then applied back to the legacy storage system. So this helped us bootstrap the migration, and because Spanner was now our source of truth, the old system became sort of like a follower replica. I'm not even kidding when I say a third of the timeline was spent working with Spanner to run Gmail and Spanner more efficiently, leading to global improvements like Spanner's more efficient Resi format. So in parallel with working with Spanner, we spent a few years building and scaling a migration pipeline that would rewrite all of our emails since 2004, all while we're still using Gmail. So one of the key technical decisions was allowing the migration to be a two-way ticket, so accounts could unmigrate if needed. We started off slow, with our own accounts, dogfooding as we call that, and then scaled up. We'd migrate a batch of accounts, find performance bottlenecks, tune the pipeline, unmigrate, and then rinse and repeat. So remember, this is all happening in production in real time. It's entirely possible that some of your Gmail accounts were zipping back and forth through our migration pipeline hundreds of times during this period. You never noticed, did you? We worked really hard on that. So by 2021, we had scaled this migration pipeline to hundreds of millions of accounts, and we were ready to start the mass migration. And this is where we ran into the Spanacles. Spanacles is a cute name we gave our edge cases. Basically, these barnacles hanging onto the side of our Spanner migration. So here's where it gets really weird. Remember, email's like an open protocol, right? So you can just fire up Telnet and send pretty much any characters you want over SMTP. So some of the emails that have ended up in Gmail over the years are unique. I'm talking, subject lines that are invalid UTF-8s, extremely large attachment names. We had this message body, completely innocuous and perfectly normal. But then there was this header with thousands of characters of someone's Git commit in it. Don't worry, you can just put that in the body. We're charging you the same. So some of you have even scheduled emails to send like hundreds of years in the future. I don't know who you think is going to be reading these emails, but thanks for almost breaking our migration system. You're very clever. So we knew we couldn't wait until the end, to handle these spannicles and edge cases. So up front, we built tools to fix them. And in parallel with the migration, we went out and fixed all of these issues that finally, thank God, has enabled us to close the chapter on the migration in May of 2023. And I'm proud to announce that Gmail is running fully on Spanner, thanks to all the hard work of the engineers. Thank you. That whole relational databases don't scale doesn't really apply to Spanner. It's proven its horizontal scalability. You're all living on it. Oh, and we love that blazing fast SQL. We're thrilled to be in a fully managed service. We get to focus on the business and features of Gmail, and Spanner continues to improve and deliver performance gains all auto-magically. Thank you to Spanner, and thank you all for listening.
That was great. I'm going to be using Spannicles in casual conversation now. It's going to be super awkward. Who wants that shirt in the Google store? Should we add that? The Spannicle shirt? That's great. Thank you for that. So, look, we've come a long way in this story as we've talked about legacy land and what's next in cloud. We looked at how AI can reshape how we think about building some of the apps. We explored brand new features for making our platforms more maintainable and secure. And now we're ready to see how the world of data is changing. I'm excited about this one. To help us with that, I'd like to invite one of my friends on stage, a legendary Google Cloud Champion Innovator, Miles Ward. Good to see you, man. Thanks for coming.
Thank you.
Yeah.
I was pretty excited about this. I brought an electric sousaphone. Did you forget yours, or?
I didn't even know what the sousaphone was like 4 days ago. I think the next Dev Keynote is just you shredding on brass instruments for like 60 minutes.
I will rock at least as hard as Spanner rocked for Gmail. Sudhiv's got it.
Yeah, I'll bring my kazoo. It'll be good. So, Miles, you help some of Google Cloud's biggest customers find new ways to cloud on a daily basis. I have to believe you're hearing a lot about AI right now.
Once or twice, right?
Occasionally.
It's not a buzzword, folks. This is an existential question for all of us as developers and businesses. I'm thinking about a project that we've done together with a customer of ours. They have not tens, not hundreds, but thousands of internal, distinct data sets of totally unmaintained lineage.
Wow.
It doesn't matter. You could have hundreds of analysts. Nobody can clean that up by hand. And we know that there's valuable insights in there, right? That's a treasure trove. But we just don't, how do you get at that? So we figured there are three big opportunities that are present. First, we have to simplify data operations, and that's got to include security. We've got to put all that data to work, be able to use it using the power of AI. And we want our cake and to eat it too. We want our choice of the best open source tools and managed services so we don't have to do so much work.
You asked for a lot, but I will see if we can turn your dreams into a reality right here, live on the demo stage. So if you recall, very back in our very first demo with Alice, we captured some unstructured audio, right?
Yep.
We wanted to get some insight on it. We kind of hand-waved away how we would do that, because that's how Forest works. But now, Miles, it is time for us to get in. Let's dive in. So I did spin up, if we jump to the screen, a typical data infrastructure using the Analytics Lakehouse Jumpstart solution. Remember, these solutions are available in the console today. They're a great way to get a head start on Google Cloud and figure out what's possible. So these allow me to spin up in minutes, what could have taken a lot longer to do before.
I love these pages.
Yeah, awesome, which we'll show now, just for the excitement. That's right. So you can guess, but just as before, see the architecture. We're using BigQuery, we're using Big Lake, Dataproc, all the things. So to start off with, first, we actually populate a bunch of those more audio files in a cloud storage bucket. Right, a lot of incidents. I don't know what's going on here. There's a lot of incidents we created. So we're going to start with these. Again, these are just audio files.
Right.
We're going to do something more interesting with them. So to work with them, I've gone ahead and created a new object table in Big Lake. So what this lets me do is it lets me manipulate unstructured data in SQL, just as if I was working with data in a traditional schema. So here I created that object table. You can see when I run the query, I'll get some stuff back. And what's cool is it's not just listing it in there, it's actually refreshing this. And it's constantly pulling in those media files, and now I have a reference to them
I mean,
this table.
just take seconds. I'm such a huge fan of how this big link model, it simplifies the security operations of working with data like this. What Richard's showing is called access delegation. So right now, you only need permission to query the big lake table in order to work with data. That means you don't need direct access to the cloud storage. You can actually swap that out with an underlying different storage layer. It could be anything. It could be S3, you could be on Azure Blob Storage, and all the permissions you need are just the access to data big lake.
I hope everybody caught that, 'cause that's a big deal when I can be swapping out that underlying storage layer. Bring your own blob, as I never say. Why am I saying that here? But that's something you would say. So the first thing we want to do before we can actually transform this data is get this into a format. Let's transcribe it so we can actually access it more easily. So I've got a BigQuery function here that goes ahead. You can see next, speech-to-text function. This is actually transcribing the data from the audio file and putting it in BigQuery. It uses the unified speech ML model to give us some high-quality multilingual output. So we can go ahead. We have that query down here, just in case you don't believe me.
Live, please work right.
Yeah, we don't have trust
right.
yet. All right, there we go. So it's there. So let's go ahead and invoke that. So I want to run this function. So it's going to go through everything in that object table, listen to the audio, and then transcribe it for us. I probably need some waiting music. There we go. Thank you. How you doing?
I mean, seconds feel like minutes.
Yeah.
That's relativity, right?
There we go. We didn't have time for a dad joke there. That was good. So if we go ahead and select from here, what we should have is a bunch of audio transcription. So using this model, look, we got all of the audio from those files now right there. Amazing.
So you don't need any complex code, no ML. There was no ML hacking done on stage today. You don't even need to leave the data warehouse. Do you have Duet AI enabled in this BigQuery project?
I'm here for you. Yeah, I absolutely do.
Okay, so let's see if you can get it to find like a specific type of safety incident, like maybe all the reports that say injury or something.
Right, because I'm terrible at writing SQL. So when I can just give it a comment and have it give me a query statement, that's making everybody better. It'll also give me some options. I might look and say, that's not the one I want, or hey, that looks close. All right, let's pick that one, run that. And what it should give me then, I'm querying that. I'm getting only 2 records back because we have injury somewhere in that audio transcription, which is awesome.
Slick, slick, slick.
Yeah, so notice how we figured out the table structure. I didn't tell it anything, right? We went from unstructured blobs of audio data to something that we as quasi-SQL developers can actually get real insight on just a couple of minutes.
I mean, we can set the bar higher than that, Richard. We can get after it. We should, put on our analyst hats.
The hell's an analyst hat? Is it like a fedora?
Like cowboy or Carmen San Diego, something like that.
Fine. So let's see if we can transform this data into something more useful. I want to get out one of the BigQuery Studio notebooks for this workload. Yeah, buckle up. So in this notebook, we can interact with structured and unstructured data in a single data frame using BigQuery data frames. This provides a pandas interface, and it pushes that work to BigQuery instead of making us have a big, large instance sitting around with tons of gigs of memory.
Right.
So in this example, we're going to use BigQuery data frames, but look, I could use Spark data frames if that was a better fit. Back to your open source thing, it's just about using the right compute for the right workload.
And I hope you are too, so excited about this combination of open source and managed tooling. Like, yep, give me Spark as the execution engine if that's what I want, alongside BigQuery as the data repository, or if I want to fine tune an LLM and PyTorch, cloud TPUs now support that. I mean, I could bring in data from Apache Iceberg now if I want to.
Simmer down, big man.
I mean, it's fun.
It's a lot. I'm super pumped. I'm going to make you even happier, though, which is troublesome. I have some data in Apache Iceberg right here. And so what I want to do, I've got this loaded in a cloud storage bucket. And I want to then go ahead and take the output of our data, also going back into Apache Iceberg format to keep with our lake principles here. So we have this managed table. Terrific. We've got some data in from that table. If I pull out this data frame reference, we can actually see the data that's in here. It's a list of supervisors. Terrific. Let's go ahead and put that back in there. Stop breaking stuff. We'll go ahead and run that, load that into the data frame. So there we have our structured data. We also have that unstructured data, right? All that audio stuff.
Right.
And so we've got that all together, which is terrific. And then we'd be able to join this later. So I could join this information, I could filter it down, see which warehouses have which incidents, and so forth, and then even identify the risky supervisors by figuring out which supervisors were in which ones of these facilities, And look, it's Stuart and Kyle. It's time for a little extra training.
I always knew Kyle was going to be a problem.
Sketchy guy. So Big Lake Managed Tables, look, we can enable this and interact with this data just like a BigQuery table, which is awesome. And as you talked about before, security is also managed at the metadata layer. So we can keep row and column data access controls consistent across the data, no matter the format or type.
We have to keep the safe path, the happy path, people. It is the only way.
I think you actually do say that. Yeah, that's the thing.
I do say that.
So as you saw, we combined all the data here, got it processed, and now it's enough information that we can work with now. So good. So by joining this, we have new information, new insight. That's terrific. Let's go ahead and then see that next step. How do we do a little more here?
Sure. So if I'm thinking about how to filter this information, maybe we could use Python to send the list to our training team, get them enrolled.
Yep, we can do that as well.
It's not just about cosmetically improving the developer experience. This is time and money, right? It's time to first insight is always our goal. If information is hard to find internally, okay, everybody at home, raise hands up. You have all the information you need. It's super easily accessible. It's no problem. Note there are no hands up in the audience. I mean, making information easily accessible and useful, that's like the Google thing, right? So maybe we should make it the easy way.
Yeah, so that's good. We've had some fun manipulating that data, but we really want to get a little more out of this. How do we get some more value? Maybe we want to summarize these incidents as well so we can find out what factories have which trouble spots, things like that, take some action, make sure people stay safe in there. So here's where it gets fun. Look, under the hood, BigQuery Studio notebooks are built on top of Colab Enterprise. This is the cloud-ready version of Google Colab notebooks that many of you have known and loved for years. So when you're ready to take off your analyst hat and put on your ML engineer hat, what hat is that? We can switch over to Vertex AI.
Okay.
Look at this. This is the same notebook. So this is the same notebook we're looking at, same data frame, same code, all of it. But now I'm using Colab Enterprise in one environment. Seamless.
Can you call Palm? Can you extend that with Vertex AI? Do summarization from there?
Yeah, so let's actually invoke the Palm API so we can summarize maybe that lengthy summary there and get back a nice little description that we can figure out which factories are a hot mess. Oh, there we go. I think you showed me the little magic wand button before. Look at that.
I like the wand,
It doesn't take a lot to please me. There we go. And so if we come back, we see there's a summary. I'm getting a single sentence summary of what might be a really long transcription. Right. And I'm doing all this in the data frame. Again, I'm not leaving my tool set.
So everybody take a minute to appreciate what just happened. We pulled in that Vertex integration, no containers or extra sidecars. We didn't stand up some giant model or run it on a bespoke massive instance in order to get it close to our data. It's just right there. It's waiting in the platform for us. It's an API a call away. And you can make that endpoint available in the AppSheet app from Alice earlier, right?
That's right. Alice is excited. We could, just an API endpoint.
So using AI to put our data to work is the driving impulse behind so many of the conversations that I'm having right now. And I just can't tell you. I can't tell you how excited I am to continue blowing people's minds with these features. This is what is going to change businesses everywhere.
I love it. So I'm right there with you. Let's have a big hand for Miles Ward, all of our champions. All right, we got some more coming up.
And now, the final legacy law.
Hi, I'm Urs Hölzle, and I work on infrastructure. But back in the dark depths of the last millennium, my first real job was to be a programmer on an IBM 370 mainframe. But then, pretty much in the first year of this job, IBM brought out their first business PC, the IBM PC. It had just 128 kilobytes of memory, kilobytes. Slow processor, pretty thin software stack, but when I benchmark it, it was actually, the performance per dollar was really good. And so, 18 years later, when I started as a search engine mechanic at this little startup called Google, it was natural to try and build it on top of PCs because their price performance was still unbeatable. And the software stack was still pretty bad, but there was this thing called Linux, which sort of almost worked. Now, physical networking was still a problem back then. It took a while to get an affordable fixed line between our first two data centers in Santa Clara and Sunnyvale. And so when it came to copying a new web index, a new search index from one place to another, it was really hard to beat the bandwidth of a Honda full of hard drives. And I'd like to tell myself it's going to be okay. In 2023, we're going to have this awesome global backbone where this index copy just takes a few seconds. But, we had to start small before we could grow into where we are today. Now, the other problem you get with thousands of PCs, with thousands of disks, is that it's kind of hard to keep track of where your data is, and disks break all the time. Now, two decades ago, one of the first things we did is we built a distributed file system to manage these disks. And then 13 years ago, we replaced it with a more resilient version that's called Colossus. And to this day, every single byte you store in Google Cloud, in a VM's disk or in GCS or in a database or in a Google Drive file is still stored in Colossus. And now the other problem, of course, with these thousands of PCs is how to manage them and how to place workloads on them. In the beginning, we had Python config files and a little MySQL database to kind of keep track of them. But then about 20 years ago, we built the first version of Borg, the system that to this day schedules all your workloads in Google Cloud. And then about a decade ago, we released a open source version built on the same ideas. You may have heard of it. What's it called? Kubernetes, that's right. And just to close the circle, mainframes are still around. And today, you run Kubernetes on them. So in fact, that's kind of the story of almost every software and hardware project and software and hardware stack. For sustainable success, you need to learn the lessons from the past and, so you can invent the future, right? And some call that legacy. I call it building on the shoulders of giants. And after 20 years in management, actually recently, I've returned to my roots as an engineer, and so I'm going to be working with the giants on our technical infrastructure team to continue shaping the new way to cloud. And all of us at Google are really looking forward to seeing what you will build next on that cloud. Thank you.
That was awesome. So look, what's in the legacy? Today, we've seen that the way we prototype our apps, the way we modernize our platform, secure our workloads, even the assumptions we have about our data, they're not choices that we have to be trapped in the past. We can challenge our assumptions even while we celebrate what came before.
That's right. And now it's time for all of you to go build your next legacy. But don't go just yet. Until then, our champion innovators have helped us see that taking the next steps toward that new way to cloud, it requires more than just technology, doesn't it?
True.
It takes human creativity. It takes empathy.
Right.
It requires us working together in harmony with a rhythm.
All right.
Taking cues from our roots, even as we tune up a new legacy.
I feel like you're alluding to something specific here.
Yeah, listen, we started with music today. We're going to end with a little bit of music. So to help us wrap things up today, please welcome our very special guests, Black Thought and Questlove from The Roots. Whoa! Thanks for coming out, guys.
How's it going? Hey.
Good to see you. Thanks for coming.
Thanks for having us.
Good to have you here.
I hear you guys are having computer problems.
Yeah, we just turned it off and on again. We're fine. So Questlove, you're on tour with LL right now. You're celebrating 50 years of hip hop. How's the tour going?
The tour is amazing simply because, these are people that we vitalized since, we were in high school. So to be with them every night and, to be peers, not idols, but right there amongst them is probably the most incredible thing ever.
It's a dream come true every night for us.
That's awesome.
And the fact that it's, the lineup changes daily is just, the icing on the cake. So
Oh, that's fantastic. Well, 50 years of hip hop, incredible. We thought it might be fun to ask Google Cloud's AI about some of those great moments in hip hop history. You all up for that?
Sure.
Oh, yeah.
Let's do it. All right, let's give it a try.
What can go wrong?
I'm going to pull up Generative AI Studio here in Google Cloud, and we're going to see if we can maybe show a little summary of like some of the greatest moments in hip hop history, okay? And we'll see if we can maybe break them down by era. So we're pulling that up. Show me a summary of the greatest moments, breakdown of the top hip hop moments by era. We're going to run this prompt. And when those little dots stop flashing, there we go. So we've got a breakdown of the 70s, the 80s, the 90s. LL Cool J, who's on tour with you, is there, which is fantastic. So Tariq, you're one of the greatest freestylers of all time.
Yeah.
Could you give us a little freestyle about some of those hip hop moments?
Yeah. I would say the 70s would be the top of the show.
Yeah.
We had rappers like Melly Mel and Curtis Blow. In the 80s, that evolved into what we would be post Public Enemy and Run DMC. In the 90s, the culture hit a stride of its own, from LL, Wu-Tang Clan, and Sean Diddy Combs. In the 2010s, 20,000s and 2010s, it changed to anything goes. So what the future currently holds, which industry knows? I'm gonna say tech.
Fantastic. Thank you so much.
That's awesome.
Oh, that was incredible. Okay, now we have one last question for you all before you go.
Yes.
So today we've talked about some big ideas here on the developer keynote stage. Legacy, Duet AI, of course, 0 days, data lakes, containers, even mainframes we talked about, and of course, the new way to cloud. I know that's a lot. Black Thought, are you able to freestyle about any of that?
I am.
Let's do it.
I jotted a couple things down. So here we go. High school, that's where our destiny together began. This thing we built is solid. I would never rebrand. If we're apart, the show don't start. Together we can. But to some extent, we're all still in legacy land. It's the dinosaur and the tourist. Thank you if you support us. I could write a chorus or let AI create a forest just to lighten the load. Then I'm back in the mode like Duet, collaborating and rewriting the code. So to say, imagine getting to see your heroes play in some shady part of town where all the weirdos stay. You try to fix something within them, and it won't go away because they've already been exploited. It's a 0 day. Now you can change lanes, or change games, or change names. Can you change brains and stop thinking with mainframes? Personally, I'm a container. My thoughts are all flames. This is the way to take the data lake to full range. What's next? If you're rocking with the roots, say it loud. There's no reason for you to leave and regroup. Just stay around. Greatness was recited, and then the poet took a bow. I'm proud to present to you all a new way to cloud.
Woo! Thank you guys so much.
The roots, everybody.
Do it. The roots, everybody.
Thank you.
Thank you so much. Good pitch, man. Thank you.
See you tonight, dude.
Black Thought, that was incredible. Thank you.
I cannot wait for that show tonight.
We'll catch you all
So
later.
look,
You all good. Head right out. Yep.
enjoy tonight's sessions, today's sessions. Make sure you fill out those surveys so we know how to make better Cloud Next in the future. And speaking of which, I'm really pleased to announce Google Cloud Next will be back in April of 2024 in Las Vegas, Nevada. Save the date, save your money. We hope to see you there. Thank you very much. Forrest, can you and Miles play us out?
Let's do it.
Okay, Legacy Land, everybody. Here we go.